Okay, so let's talk about even functions and odd functions, and in particular, what the symmetry for the graphs looks like. Okay, so if I have a y-axis symmetry, right? If I have this symmetry in the y-axis, we call this even. Okay, and if I have this rotational symmetry in the origin, right? If I have this rotational symmetry in the origin, what we mean by that is that if I were to rotate this around, right, if I were to rotate this around 180 degrees, right, if I were to take my graph and rotate it around 180 degrees, would I end up looking the same, all right? And if that is true, then we call these functions odd. Right? And if I have a function that doesn't have this symmetry in the origin, and it doesn't have the symmetry in the y-axis, then we say that this is neither or neither. Okay, and what is interesting is that yes, I took this graph and rotated around 180 degrees, right? Well, that 180 degrees rotation, I still don't have any symmetry for the graph that was neither. Right? I do have odd symmetry for the graph that had that symmetry in the origin, because the graph up here and the graph down here, when I rotated 180 degrees, about this origin, if that happens and my graph looks the same, that's what we call odd symmetry. Okay, and of course, if I make this rotation, right, and I look and I still have my y-axis being vertical, and I still have this symmetry, right, this y-axis symmetry, we call that even. Okay, now what's some important notation for this? What's some important notation for this origin symmetry and for this y-axis symmetry? And that is this notation, that for y-axis symmetry, if I substitute in negative x, right, the output that I get is the same, right? So if I have some x value, right over here, and I say, well, what would be the value of my function at negative x? What I will find is that the value of the function would be the same. So f of negative x is equal to f of x, all right? So on this particular one, for the origin symmetry, what I have is f of negative x is equal to negative f of x, right? And we're not going to focus quite as much right now on this notation, but we will rather focus on what is the relationship between number pairs, right? And the relationship between number pairs would be that if I have some x, y coordinate, right, and I have even symmetry, I will then also have a negative x, y coordinate. Okay, this is going to be the important part for our first introductions and our first work in this course for our y-axis and our even symmetry. Okay, and for the origin or for the odd symmetry, if I have an x, y point and I substitute in negative x, then my output will be negative y, right? And really that's what this is saying. It's saying that, hey, if I input negative x, my output is negative y, right? If I input negative x, my output doesn't change, right? So here's input, here's output, change the input, output stays the same. Here's input, here's output, change the input, output changes. Okay, now what can that look like when we are going to draw? What can this even and odd symmetry look like if we have to draw it ourselves, right? So here are a couple of graphs. Here are a couple of graphs, right? And I'm going to go ahead and for this first one, I'm going to pick a couple of points, right? I'm going to pick a couple of points that I can see and that I can tell and say, that if I have even symmetry, these points are going to be reflected across this y-axis. Okay. Now for this odd function, if I pick some simple points, right? For this odd function, if I pick some simple points that I can tell, then what's going to happen for the odd function is that I'm going to have this have rotational symmetry, which means that I'm going to have to consider, right, what my function will look like if I flip it upside down. And really what we're saying is that if I rotate this function 180 degrees, this is what the other side of my function should look like. It should look something like this. And if I rotate it 180 degrees back, right, then I have where I am originally. So I'm going to go ahead and plot the points, and let's see what this is going to end up looking like. So I started with the even function and plotted the points that were reflections in this y-axis, right? So this point here was 1 unit to the left, so I reflected 1 unit to the right. Here, 2 units or 3 units to the left, so then I had 3 units to the right. Okay, over here on the axis, I stay on the axis, and over here I was 2.5 units to the left of the axis, so I go 2.5 units to the right of the axis. And then to complete my graph, I simply need to connect the dots. And so in playing connect the dots, this would be what my even symmetry looks like. Okay, and notice that if I were to turn this graph around 180 degrees, rotate it 180 degrees, it doesn't look the same as my previous graph, so I don't have odd symmetry. But the symmetry in the y-axis is still there, so I still say that this is an even function. Okay, go ahead and rotate it back, and now let's work with the odd function. I'm going to go ahead and look at how I'm going to plot these points. So I come over and I plot the points. And a lot of times plotting for odd functions can be more difficult for students when they're initially working through it. And so that's where I come through and I use my notation for an odd function. That if I have an xy point, it becomes negative x, negative y. All right, so 0, 0 stays at 0, 0. Right, but this point here at negative 2, 0 is going to change to be at positive 2, 0. Right, and this point at negative 2.5, positive 1, is going to move to positive 2.5, negative 1. Right, this point over here at negative 3, negative 2 will become this point over here at positive 3, positive 2. And then finally, this point down here at negative 1, negative 3 will become the point positive 1, positive 3. All right. So then my next piece would be to play connect the dots, come over, try and get as close as I can to my graph. And so now there I have my odd symmetry. And once again, if I rotate this 180 degrees, my graph should look the same. That's rotational symmetry in the origin. We call that odd symmetry. Okay, so those are things that we need to know about symmetries for even and odd functions, and those types of symmetries that we can have. Okay, thank you very much for your time.